2 weeks ago, this device cloned a key card. Last week, it stole a password with a fake Wi-Fi page. Today, it's going to type on a keyboard faster than any human ever could, the moment you plug it in. This is bad USB, and it's the feature that makes IT departments genuinely nervous, because it doesn't exploit a bug, it exploits trust. Computers trust keyboards completely, by design, so if something can pretend to be a keyboard, it can do almost anything a person sitting at that machine could do. Today I'm writing a payload from scratch, showing you how the scripting language works, and talking about where this stuff sits, legally and ethically, before you go anywhere near it. Own hardware, full transparency, let's get into it. Welcome back to the Tinkerer's Lab. If you've been here the last 2 weeks, you've seen the RF side and the Wi-Fi side of this thing. Today's a bit different, no radio at all, just a USB cable and a script. Quick note before we start, everything today runs on my own laptop, and every payload is something you could type yourself in under a minute. There's no mystery hacking here, that's actually the point. Here's the concept in one line. When you plug a normal USB keyboard into a computer, the operating system doesn't ask for a password or check a certificate. It just trusts that anything identifying itself as a human interface device is, in fact, a human at a keyboard. Bad USB takes advantage of that. The flipper, or really any small microcontroller with USB support, tells the computer I'm a keyboard, and the computer believes it. From that point on, whatever keystrokes get sent, the computer treats exactly like typing. The difference between this and an actual person typing is speed. A skilled typist might hit 80, maybe 100 words a minute. The flipper can inject keystrokes at a rate no human hand could match, which means a script that would take you 2 minutes to type by hand runs in about 2 seconds. That's really the entire threat model. Not a virus, not a software exploit, just extremely fast, unattended typing. The scripting language behind almost all of this is called Ducky Script, named after the rubber ducky, the device that popularized this whole category of attack years before the flipper existed. It's deliberately simple. Link to this wiki is in the description. Every line is either a command or a delay. Let's start by plugging in our rubber ducky. We'll give it a brief moment using delay to initialize and register as a USB keyboard. First, the script triggers the GUI key, which opens the start menu on Windows or the activities overview on Linux. We pause for a second here to make sure the search bar is fully loaded and ready for input. Next, the ducky quickly types out terminal to locate our command line interface, and hits enter to launch it. We've added a 1.5 second delay here, just to ensure the terminal window completely opens up before the next command. Now it types nano and presses enter, which opens up the standard command line text editor. After a tiny fraction of a second to let nano load, the script types our final payload message, hello, and with a final press of the enter key, the automation is complete. The Flipper 0 supports JavaScript as well, but that deserves its own tutorial, which I will do later in the series. Scripts live as plain text files on the Flipper's SD card in the bad USB folder. You can write them on your computer in any text editor and drag them across. No compiler, no special tools. Let's build one together, something harmless, so you can see the whole process end to end. I want a script that opens Notepad and types a short message. First line, delay 1000, just to give the computer a second to register the connection. Then GUIR to open the run dialog. Another short delay. String Notepad, enter to launch it. One more delay so Notepad has time to open. And finally string, followed by whatever message I want typed. Save that as a text file, drop it into the bad USB folder on the SD card. and it shows up as a script on the flipper immediately. No rebuild step, no restart needed. Now, plug it in, select the script, and hit run, and there it is. Windows key, run dialog, notepad, message typed, all in about 2 seconds, completely unattended. That's the entire mechanic. Everything else you'll see online, scripts that open a browser, change a desktop background, or send a webhook, is built from the exact same 4 or 5 commands, just chained together and timed correctly. There's no deeper trick underneath it. There's a large community library of pre-written payloads floating around online, organized by what they're meant to demonstrate. Things like exfiltrating saved Wi-Fi passwords, disabling security software, or opening a reverse shell. I'm not going to walk through any of those line by line, and that's a deliberate choice, not an oversight. The point of this series is understanding how the mechanism works, not handing out a ready-to-run toolkit. If you understand the 4 commands from the last section, you already have everything you need to read and evaluate any script you come across, which is a much more useful skill than copy-pasting one you don't understand. What's worth knowing is that the sophistication in these payloads is almost never in the typing. It's in the targeting and the timing, knowing which menu to open on which operating system, how long to wait for it, and what to type once you're there. That's genuinely just patient scripting, not some kind of exotic hacking. Let's talk about limits, because they matter more than the demos. Bad USB needs a logged-in, unlocked session to do anything meaningful. Plug it into a locked computer and a Ducky Script can type all it wants into a password field. It doesn't know the password, and typing garbage into a lock screen doesn't get you in. This is not a way to bypass a login. It also requires physical access to the machine. There's no remote version of this. Even the Bluetooth version needs prior pairing. Someone has to plug the device in, which means every single demonstration of this technique doubles as a physical security test. And legally, running any of this against a device or network you don't own or don't have explicit written permission to test is a criminal offence in pretty much every jurisdiction with computer misuse laws, Australia included. Everything you've seen today was run against my own laptop. That's not a disclaimer for the sake of it, it's the actual legal line. The practical defense, if you manage devices for other people, is simple. Disable auto-run where you can, lock screens when you walk away, and treat an unattended USB port the same way you'd treat an unlocked front door. Next week we're combining everything from the last 3 videos into one build, an ESP32 and the flipper working together as a single portable RF and Wi-Fi testing kit. Sub-gigahertz, Wi-Fi and bad USB all in one case. If you've been following along, that one ties the whole series together so far. So, that's bad USB. Not a virus, not an exploit. Just a device pretending to be a keyboard, typing faster than a person ever could into a machine that already trusts it. Understanding that mechanism is the whole point, because the moment you see it for what it is, you also see exactly how to defend against it. Lock your screen, mind your ports, that's most of the fix, right there. If you found this useful, subscribe for next week's build, and I'll see you then.